Okay, question number 15. So here we go. We are adding fraction and some decimals together. We've got -2/5 plus 0.5 plus 0.75, and they want it expressed as a fraction in simplest form. Okay, so we're going to have to get this expression into as fractions. We could either convert these to fractions and go from there, or we could convert this to a decimal and add everything up as decimals and then finally convert to a fraction. So there's two different ways we could do this. I'm going to do this, at this time, since we're trying to get to a fraction in the end anyways. Now, I'm going to convert these first to fractions. So decimals are fairly easy to convert to fractions, honestly. So we just have to look at the place that the last number after the decimal occupies. So if this occupies the 10th place, that means I'm talking about 5/10. If this number here after the decimal goes up to, we have the 10th place and then the 100th place. So we have 75/100ths, right? So that's an easy conversion. So why don't we do that? Let's do method one. We'll do it this way. -2/5. Then we have plus. We can write 0.5 as 5/10. And then we have plus 75/100ths. Now we're operating with fractions. As we know, to add fractions, we need the same denominator. So fortunately, these numbers are going to be easy for us to get a denominator, a common denominator with, okay? So, and that's why this is a problem that's good to do this way. If this fraction gave us some other decimal that was kind of weird or strange, maybe it wouldn't be the best way. It would be better to convert this to a decimal than add decimals, right? But this is going to work just fine. So here, let's try to get everything to be over 100. Then it'll be easy to add, and that's easy to get there. Here, we're just going to multiply top and bottom by 10, get an equivalent fraction that's over 100. And what do we need to multiply 5 to get to 100? So we're going to multiply 5 times 20. 5 times 2 is 10. If we add a 0 to that, it would be 100, right? So 5 times 20, right? 5 $20 bills gives you $100. Okay, so let's rewrite this here. So we've got 2 times 20. Don't forget the negative. 2 times 20 is 40. 5 times 20 is 100 as we wanted, plus 5 times 10 over 100 because 10 times 10. And 75 over 100, we already have that. Now we can add our numerators. Okay, so we've got -40 plus 50. We have -40 plus 50 opposite signs. So we have to take the difference. It's 10. And since 50 is bigger, it would be positive 10. So we're going to get 10 over 100 from this first bit here. And then we're going to add our 75 to that. So we get 10 plus 75 is 85. Great, we have a final answer. It's a fraction, but it's not yet in its simplest form. So we want to try and divide top and bottom by something that will divide into both. So easy first one I can see is that anything that ends in a 0 or 5 we know is divisible by 5. So let's reduce that. Okay, so we've got 100 divided by 5. Well, that's easy because we just said 5 times 20 was 100. So 100 divided by 5 is 20. And what about dividing by 85? We could say 85 divided by 5 and do it long division. If that works for you, that's fine. Do that. I also know that for every 10 that I have, I've got 2 5s, right? So 5 goes into 10 2 times. So for every $10 bill, I could change a $10 bill for 2 5s, right? So I'd have 2 of them. So I could just think 2 times every grouping of 10 I have here. If I have 80, I have 8 times 2 groupings of 5. So I would have 16, and then I have one more $5 bill. That would make 17. Okay, so I'm just trying to do a little mental math there, right? Or you can do it this way, right? So long division, 8 divided by 5, that can go in one time. So we would get 5 times 8, it's 50, right? So we get 85 minus 50 would give us 35. Now we're how many times can 5 go into 35? We know 5 times 7 is 35. 35 minus 5 is 0, so we're done. So we get 17. Okay, however you do it, you can get that answer, 17 over 20. Nothing we can reduce further. 17 is a prime number. Nothing divides into both 17 and 20, so we're done. Yeah, and I think I'm just going to leave it there. The alternate method, well, here we go. If you want to see it, there's another way we could do this, but this is really quite nice for this problem. So I think this is the way I would go with. I think that's a better way to do it. But we could convert 2/5 to a fraction. Okay, so we could say 2 divided by 5 is 0.4 if you do long division. Or you could also, if you have something like 2/5, we know if we multiply top and bottom by 2, we get something like 4/10. Now that's easy to see as a decimal. That's written like that, 4/10. Don't forget that it's negative. So then we could do that. 0.4 plus 0.5 plus 0.75. Now you add that up however works for you if you want to do it vertically, or if you can do this in your head. We've got 0.5 and 0.4. The difference would be 0.1, and it would be positive, right? Because this is bigger. Then we add that to 0.75, and we would get 0.85. Now, we want it as a fraction. Again, converting decimals to fractions is easy. We're not in the tenths place. We're all the way over to the hundredths place. We're talking about out of 100. So I have 85 over 100. Now we're at the same step here. We reduce that same as we did before. We get the same answer, okay? So there's two different ways you could go about doing that, whatever works for you, all right? Okay, next question. Again, I'm just going to keep moving on. You pause the video if you need to, as you need to. Question number 16, which point best represents the location of the square root of 17 over 81 on the number line shown above? Well, I know that I don't know the square root of 17, but I do know the square root of 81. So if I broke this up into two square roots, because you can do that if you have a fraction, we can take the square root of the top and the square root of the bottom. Now on the bottom, square root of 81 is 9. On the top, I'm not sure, so I'm going to go for the closest perfect square. So we got to think of perfect squares. 2 squared is 4, 3 squared is 9, 4 squared is 16. That looks pretty close. 5 squared is 25. That's farther away. That's not a good substitute. So I could replace this, and I'm going to say approximately, or there's different ways that we can write that. You might see it like this, an equal sign with a dot above, meaning approximately. It's close to the square root of 16. Okay, so the square root of 16 is 4. So we're going to be close to 4/9. So we're close to 4/9. Let's go find this up here. So here's my 4/9. Uh-oh, I've got 2 points. Point number 1 is close, and point number 2 is also close. But which side? This is more positive, right? This is going to be bigger, and numbers going this way are smaller. So am I to the right of 4/9 or to the left of 4/9? Well, this is not, we're estimating that this is close to 16, but is 16 bigger or smaller? Sorry, 17 bigger or smaller than 16? It's bigger. So that means our answer is also going to be bigger. So it's got to be here. So it's going to be point number 2. We're going to fill that in on our numeric response. There's your answer. Point number 2 is your correct answer. That's the point that's closest to 4/9. It's on the correct side of 4/9. So again, let's go back to this number line if this helps. Okay, so remember, I know 16, if I take the square root, here it is, it's 4. I said 25 is my next perfect square, that's 5. 17 is right about here, okay? If I take the square root, I don't know what that is exactly, but I know it's really close to 4. It's 4 point something. So if I have a number that's a little bit bigger than 4, I'm just going to call it 4 plus, okay? Something a little bigger than 4. So instead of 4, the square root of 17 is approximately 4, but it's bigger than 4. So it's kind of like our 4 plus, right? A little bit bigger. Okay, so our answer is a little bit bigger than 4/9. All right, if this problem was instead the square root of 15 over 81, we would have said 15 is close to 16, and we also would have said it's approximately equal to 4/9. Okay, but 15 is over here. And the square root of 15, even though it's close to 4, and we can estimate it as 4/9, it's actually a little bit less than 4/9, right? So maybe I would call that 4 minus, right? Something a little bit less. So it would end up being 0.1 in that case. But we had 17, which is a little bit bigger than 16. So our number is a little bit bigger than 4. So we're to the right of 4/9. All right, so there we have it. Question number 16 done. Question 17, what is the value of 2 to the power of 3 minus 3 to the power of 2, all in brackets, and then to the power of 2? Okay, so order of operations, brackets, exponents. So we do what's in, right, BEDMAS. So we do what's within the brackets first, if there's something to do here. And there is. We have some stuff going on. Okay, so we're going to do our stuff first, if possible. Now, they're also trying to trick us here. People are going to see some numbers, a 2 and a 3, a 3 and a 2. We're thinking, oh, power rules. I think when it's subtraction. Oh, I can subtract those powers. And then, but what do you put as the base? Well, you might end up start making things up. We don't want to do that. Okay, so remember, our power rules only apply to things like, first of all, we have to have the same base, meaning this big number here. And say I had I'm doing a separate example right now, okay? And if I had something like this here, when I have the same base and I have the same power, I could add these together if I'm multiplying, okay? Or maybe I'll put a little multiplication sign. If I'm multiplying and these have the same base, then I could do stuff like this where I add exponents, okay? But first of all, here I have a couple problems. One, I don't even have the same base. That rule doesn't apply because we have a big 2 here and a big 3 here. Secondly, we're not multiplying or dividing. Those rules don't apply. This is subtraction. So we're not going to be able to do anything like that. We just have to calculate those values. So we're not going to try simplifying that stuff, okay? Again, what I wrote there was not representing these numbers. That was a different example just to show you what we can do. But here we can't do that, okay? So we just have to figure that out. What's 2 to the power of 3? Hopefully we know by now that's 8. 2 cubed is 8. If not, though, 2 times 2 times 2. Work it out, you get 8. Then we're subtracting. What are we subtracting? 3 to the power of 2. 3 times 3 is 9. 3 squared is 9. We still haven't finished. Still haven't done that, so don't forget to put that in there. 8 minus 9. Difference between 9 and 8 is 1. 9 is bigger, so since we're subtracting a larger number, we're going to have a negative number there, 1. Now, we have a negative number, but we know our exponent is even, so our answer should be even. So 1 squared, okay, is 1, and our exponent's going to be, our sign is going to be positive because we have an even exponent. So we get positive 1. The other way to think about it, we can expand it, negative. What we're literally doing is we're multiplying negative 1 times itself twice. Negative times negative is a positive, 1 times 1 is 1. So we get positive 1, okay, or just 1, right? We don't need to see that sign. So on your answer sheet, you're going to put 1. There you go. Okay. Question number 18. All right, what is the value of the square root of 1/9 times the square root of 36 over 49 times the square root of 49 million? Okay. We're pretty familiar with this. Maybe we haven't worked with big numbers like this too much, but it's not a problem. Let's see. We are going to do it this way. So let's figure these out one at a time, okay? And then we're going to multiply them all together. All right, so we have 1/9. We can take the square root of 1, which is 1. We can take the square root of 9, which is 3. That's an easy one, okay? Done. We have square root of 36 over 49. We recognize these are both perfect squares. So we can take the square root of the top. Square root of 36 is 6. Square root of 49 is 7. So I have 6/7. I'm just pausing there while you're going 6, 7. Okay, and then we have the square root of $49 million. 49 million. Okay. So we know the square root of 49. That's easy. We know that's 7. And now think about something here. What is 10 times 10? Okay, 10 times 10 is 100. What is 100 times 100? How do we, when we're dealing with numbers like this, what do we do with the zeros? If we have 2 zeros here and 2 zeros here, if we have 100 and 100, we can just add those zeros up. So we get 1, 2, 3, 4 zeros, which is actually 10,000. What if I had 1,000 times 1,000? We would have 6 zeros. We would have 1, 1, 2, 3, 1, 2, 3, which would be $1 million. So if I have the square root of 49 million, I know my square root of 49 is 7. My million parts, when I take the square root, is going to give me my root. What was multiplied by itself to get 1 million was 1,000. Okay, so square root of 49 million is going to be 7,000. Okay, 7,000. All right, so we've got our numbers. Now we're just going to multiply them together and see what we get. So we've got 1/3 times, this gave us 6/7 times 7,000. All right, so everything on the top's multiplied together, everything on the bottom is multiplied together. Instead of multiplying, it's getting huge numbers. I mean, we could, but if we already have things broken up into stuff that can simplify, right? So realize this all multiplies together. 1 times 6, well, that's just 6, right? Times 7,000. And on the bottom, 3 times 7. I know it's 21, but I'm just going to write it like this because I can see that I'm going to be able to simplify some stuff here. Okay, so this is like saying 6/3 times 7,000/7, right? That's another way you could think about it. 6/3 times 7,000, over 7,000. Because remember, when we multiply, as long as there's no addition or subtraction involved, which there isn't any here, we're just strictly multiplying, we can separate these fractions like so, right? Because 6 times 7,000, we multiply numerators, we multiply denominators. So whether we've written it like this or this doesn't really matter. So now I've separated, maybe it's just easier to see, okay, that I can simplify this. I can divide top and bottom by 3, right? 6 divided by 3 is 2, 2/1. Do we really need to see the one on the bottom? Not really. 7,000 divided by 7 is 1,000. So 2 times 1,000, 2,000, okay? So there you go. Let's check the answer key on that one. I'm just curious how they went about doing it. Okay, so very much the same. I did a little bit more moving stuff around, so in a way that I thought might be easier for you to see, but you can see they've done the same thing. 1/3 times 6/7 times 7,000. Here we did this divide, and we divided the top here by 3 and the bottom by 3, leaving me with a 1 here and a 2 here. And then if we multiply it all together, we've got 1 times 2 is 2, 1 times 7 is 7, so 2/7 times 7,000. Okay, then they wrote it in this form, 2 times 7,000 as 14,000. 14,000 divided by 7 is 2,000. You see there's more than one way to do a problem, so you do whatever one works for you. As long as it makes sense to you, you feel confident that you could do this, and that you understand the steps, then you're good to go. All right, carrying on. Are we at 19 minutes already? How many questions did I get through? I don't know. Okay, I'm going to pause the video here and upload another video for your viewing pleasure.